Forests are always changing. They're a very dynamic ecosystem. We've used data from the Landsat satellites to produce a comprehensive look at forest dynamics on the scale of human management and natural disturbances. Dark green pixels had no disturbances in the 25 years studied. Yellow shows where a disturbance happened in a particular year. At this scale, what really stands out are the large fires in the west and timber harvesting in the Pacific Northwest, Maine, and all across the southeast. We need to know the rate of disturbance and how that rate is changing in order to understand how carbon is changing across the landscape. Here we can see the impact of policy decisions on forest dynamics. The various protected areas around Broken Bow Lake remain largely undisturbed compared to the surrounding region, which flickers with the telltale patches of timber harvesting. Any disturbance, whether from fire or hurricanes, mining or logging, impacts how much carbon the forest can store. The southern and central Appalachian Mountains, from Tennessee to West Virginia, are home to most of the disturbances resulting from mountaintop removal mining. Throughout Appalachia, coal mining has been a big industry since the 1860s, and mountaintop mining became dominant over the last 30 years. The Hobet Mine in Boone County, West Virginia, existed before 1986 and has continued to expand throughout the course of this study. The pattern we see at the Hobet Mine is replicated across the entire southern Appalachia. We mostly think of hurricanes wrecking houses, flooding cities, and endangering lives, but they can also damage forests, knocking down wide swaths of trees. Hurricane Hugo was a Category 4 storm when it struck South Carolina in September of 1989, and the scale of the disturbance shows in the 1990 data. 4.5 million acres of forest were affected by wind gusts and storm surges of salt water. Disturbances of this magnitude can release large amounts of carbon dioxide into the atmosphere as the trees decompose. Tornadoes leave long tracks of damaged forests in their wake, showing as a bright line in the satellite imagery. These long, straight tracks are extremely distinctive of this type of disturbance. On Mother's Day in 2008, several tornadoes in Georgia left a track 150 kilometers long and about 2 kilometers wide. For many tree species in the Rocky Mountain West, fire is a natural part of their life cycle, clearing space for new growth on the forest floor and releasing seeds from their pine cones. But climate change is projected to increase the intensity and frequency of wildfires. In 1988, Yellowstone National Park endured the largest fire ever recorded there. Many individual fires combined to damage 36% of the park, burning for several months. The scale of the disturbance is apparent in the following year's disturbance map. Less than 30% of the burned area regained forest cover by 2008, and the rate of recovery across Yellowstone has been quite variable, depending on the fire intensity and local conditions. Forests have always dealt with outbreaks of insects that can damage trees. Northern Colorado, near Rocky Mountain National Park, did not have severe damage from mountain pine beetle before 2003. But the damage starts appearing in 2004 in low areas and spreads to higher elevations over the next few years. Climate change may result in more frequent episodes and trees less able to withstand the stress, but this will vary from region to region. Forests are a dynamic ecosystem, and we need to know how fast they change and what is driving those changes if we ever hope to track how much carbon they're pulling out of the atmosphere and storing for us. The Landsat archive and other remote sensing systems provide the means to map and measure disturbance rates over the last 40 years.